In the last section, for this week, we're going to look at exponential and logarithmic equations and how to solve them. So to solve equations, we've done things like add or subtract from both sides, multiply or divide from both sides. We're going to add some things here that we could do, okay? Now, the first thing is what I call the switcheroo. So here's what it is. It is, if we have log base b of x equals y, that is equivalent to b to the y equals x. Now, why does this help us? Because often we will need to change our equation from a logarithm to an exponential in order to solve the equation. Occasionally, like in this case, we'll need to do vice versa and change to a logarithm. So to change 10 to the x minus 3 equals 20 to a logarithm, we'd have log base 10 of what's in the x spot, that's 20, equals the exponent x minus 3. Now, why does this help us? Because log base 10 is just log in our calculator or Desmos. We don't have to worry about the base because it's a common log. And we can easily solve this for x by adding 3 to both sides. So x will be log of 20 plus 3. And that can be put in your calculator easily to get 4.301. What's something else we could do? Well, if we've got this case, you've got a rule that says, let's see, if you've got x, we'll just say x to the m is equal to x to the n, then you can say that m is equal to n. So basically, if the bases on either side of the equation are the same, then you can set the exponents equal. Unfortunately, in this case, 7 and 3 aren't the same, and we couldn't get them to be the same. But you can also do something that will help, and that is natural logging, or logging, either way, both sides. So I'm going to say natural log of 7 to the x plus 4 equals natural log of 3 to the 3x minus 2. Now, why does that help us? Because of that rule that we learned back in the previous section that said log base b of m to the p is equal to p times log base b of m. We can bring the exponents out to the front. So we'll have x plus 4 times natural log of 7. And notice how I put that in parentheses because it's the x and the 4 being multiplied. So got to keep it in parentheses. And 3x minus 2 times the natural log of 3. From here, it's common algebra, but it is a bit lengthy because we have to distribute our natural log. So we'll have x natural log of 7 plus 4 natural log of 7 equals 3x natural log of 3 minus 2 natural log of 3. Now the next step is to get your x's on one side and anything without an x in it on the other. So I'm going to start by subtracting 3x natural log of 3 from both sides. So we'll have x natural log of 7 minus 3x natural log of 3. And while I'm at it, I'm going to go ahead, and you could do this in separate steps, but I'm going to go ahead and subtract this 4 natural log of 7 from both sides to get it on the other side. So we'll have negative 2 natural log of 3 minus 4 natural log of 7. Now both my x terms are on the left and the non-x terms are on the right. At this point, we can factor out x on the left. And keep in mind that natural logs, or logs, no matter how many of them there are in your problem, are just numbers. So this is just saying like 3x equals 2. Okay, seriously. At this point, divide both sides by what's being multiplied by x. That's natural log of 7 minus 3 natural log of 3. So x will be negative 2 natural log of 3 minus 4 natural log of 7 over natural log of 7 minus 3 natural log of 3. Just put that in your calculator. Make sure you put the top in parentheses and the bottom in parentheses when you put it in your calculator or Desmos, and you should get 7.394. Solve the equation log of 3x plus 1 equals 1. Well, in this case, I'm going to use the switcheroo again, because this is the same thing as log base 10 of 3x plus 1 equals 1. Now let's remind ourselves of the switcheroo. So log base b of x equals y is equivalent to b to the y equals x. So we can say our base, that's 10, to the thing in the y spot, that's 1, equals the thing in the x spot, 3x plus 1. And so we've just got 3x plus 1 equals 10. Subtract 1 from both sides, divide by 3, and you're done. Now, whenever you've got a log in the problem, in the original, okay, you need to check yourself and make sure that what you've found will work, okay? If you end up with a log of a negative number, it won't work. So if we plug in 3 here, 3 times 3 is 9, plus 1 is 10, log of 10 will be just fine. So it does check out. For our next example, we're going to have to use, let's see, let's use the fact that log base b of m, if that's equal to log base b of n, then we can say that m equals n. There may be other ways to do these problems, or you may try something that doesn't work. Just use all that you have available to you to try them out. So we'll have 2. I'm going to add the log base x of 2x minus 1 to both sides, and you'll see why I'm doing this. So we have 2 log base 3 of x equals log, I'm pretty sure that's supposed to be a 3, of 2x minus 1. Now you can see how we've got log base 3 on both sides. But before we can do anything, we need to put that 2 on the exponent, okay? Because otherwise we've just got a 2 hanging there, and that's not okay. So log base 3 of x squared equals log base 3 of 2x minus 1. Now that we've got log base 3 on both sides, we can get rid of it and set them equal. X squared equals 2x minus 1. We've got a quadratic, so we got to get everything equal to 0. So subtract 2x, add 1, equal to 0. And this one will factor. -1 times -1 will give us +1, and -1 plus -1 will give us -2x. So x plus 1, or x minus 1, excuse me, just one of them, so we don't need to do it twice. And we have the solution x equals 1. Now go back up here and make sure that works. If we plug in 1 here, yes, that's okay. If we plug in 1 here, 2 times 1 is 2. 2 minus 1 is 1. That's okay. We can't end up with a negative number. So our solution is x equals 1. And let's look at one more example here. So for this one, I think we've got this 2 plus, so we can't just set things equal like we did in the previous problem. So I think the easiest thing to do here would be to get the logs on one side. So I'm going to subtract log base 2 of 3 minus x from both sides. And we still have a 2 left on the left. Now, how does that help me? Remember, subtraction will condense to be addition, or be division. So log base 2 of x squared minus 20 divided by 3 minus x. And at this point, we can do the switcheroo. So our base, that's 2, to our equals, that's 2, is equal to the of x squared minus 20 over 3 minus x. 2 squared is 4. Multiply both sides by 3 minus x to get rid of the 3 minus x on the bottom. So we'll have 4 times 3 minus x equals x squared minus 20. Distribute. And we need everything on one side set equal to 0. So let's see. Add 4x to both sides. And subtract 12. Negative 20 minus 12 is negative 32. And at this point, we can factor. Eight and negative 4 will work. So negative 8 and 4 could be our solutions. However, remember, we have to go back and check, okay? So taking negative 8. Negative 8 squared is positive 64. 64 minus 20 is 44. So that's good. And then plugging in negative 8 there, 3 minus negative 8 is 3 plus 8. That's 11. So negative 8 checks out. Let's try 4. 4 squared is 16. And 16 minus 20 gives us negative 4. Cannot take log of a negative. So automatically 4 isn't going to work. But if it works in the first one, be sure and check in the next. 3 minus 4 will also give us a negative 1. So 4 is not going to work. And x, negative 8, is our only solution.